Our solar system, a cosmic ballet of planets, stars, and celestial wonders, has always captivated humankind. Among its many mysteries, the story of Pluto stands out as a tale of discovery, reclassification, and the ever-evolving nature of scientific understanding. Pluto, once considered the ninth planet from the Sun, has been the subject of much debate and controversy since its discovery in 1930. For decades, Pluto held a special place in our hearts, the little planet that could. School children memorized its name alongside the other 8 planets. We marveled at its distance and icy composition. However, the advancement of scientific knowledge and the discovery of new celestial objects in the outer reaches of our solar system led to Pluto's reclassification as a dwarf planet in 2006. This decision, made by the International Astronomical Union, sparked controversy and debate that continues to this day. Was Pluto unfairly demoted, or did the IAU make the correct scientific call? To answer these questions, we must delve into the fascinating story of Pluto, from its discovery to its current status as a celestial enigma. This essay will explore the Pluto controversy, examining the scientific basis for its reclassification and the public's response to this significant shift in our understanding of the solar system. The story of Pluto begins in the year 1930, a time when the mysteries of the cosmos were still largely uncharted. At the Lowell Observatory in Flagstaff, Arizona, a place dedicated to the exploration of the universe and the search for new celestial bodies, a young astronomer named Clyde Tombaugh, just 24 years old at the time, was tasked with a monumental challenge finding Planet X, a hypothetical planet believed to exist beyond Neptune. This hypothetical planet, believed to exist beyond Neptune, had been predicted based on irregularities in the orbits of Uranus and Neptune. Tombaugh's task was daunting, requiring immense patience and precision. He spent countless hours meticulously examining photographic plates, comparing images of the night sky taken days apart. Each plate was a window into the vast expanse of space, holding secrets waiting to be uncovered. These plates, captured by the observatory's powerful telescope, held the key to uncovering any faint, moving objects that might betray the presence of Planet X. The task required a keen eye and unwavering focus. Night after night, Tombaugh painstakingly scanned the plates, his eyes searching for any sign of movement. The work was tedious and exhausting, but his determination never wavered. Finally, on February 18, 1930, his persistence paid off. After months of tireless effort, he made a groundbreaking discovery. He noticed a faint dot that shifted position between 2 images taken on January 23rd and 29th. This tiny speck of light, barely visible against the backdrop of stars, was the clue he had been searching for. This tiny speck of light, barely visible against the backdrop of stars, would change our understanding of the solar system forever. It was the first sign of a new world, a distant and mysterious planet. The discovery of Pluto, as it was later named, was a major scientific achievement and a testament to the power of human curiosity and determination. It marked a new era in astronomy and inspired future generations of scientists. Tombaugh had found what seemed to be the long-sought-after Planet X, a 9th planet residing in the frigid outskirts of our solar system. This discovery expanded our understanding of the solar system's boundaries. The world celebrated this astronomical triumph, and Pluto took its place as the newest member of our solar system's planetary family. The discovery was hailed as a monumental step forward in our quest to understand the universe. For over 70 years, Pluto enjoyed its status as the 9th planet, capturing the imagination of people worldwide. It was a beloved member of our solar system, often featured in textbooks, documentaries, and even in popular culture. Children learned about it as the distant, icy world that marked the outer boundary of our planetary family. However, as our understanding of the universe expanded, so too did our knowledge of the solar system's outer regions. With advancements in technology and more powerful telescopes, astronomers began to uncover new and intriguing details about the cosmos. The discovery of the Kuiper Belt, a region beyond Neptune teeming with icy bodies, would ultimately challenge Pluto's planetary status. This vast, donut-shaped region is home to countless objects, some of which are similar in size to Pluto, raising questions about what truly defines a planet. To understand why Pluto was reclassified, we need to delve into the criteria that define a planet. These criteria were established to bring clarity and consistency to the classification of celestial objects. In 2006, the International Astronomical Union, the governing body responsible for astronomical nomenclature, established three criteria that a celestial object must meet to be considered a planet. 1. Orbiting the Sun. This was a pivotal moment in astronomical history as it set the stage for re-evaluating many objects in our solar system. This criterion is fairly straightforward. A planet must be in orbit around the Sun, as opposed to another star or celestial object. This ensures that the object is part of our solar system and not a rogue body wandering through space. 2. Hydrostatic equilibrium or roundness. This means that the object must have enough mass for its gravity to shape it into a nearly round form. A planet must have sufficient mass for its own gravity to pull it into a nearly round shape. This is a key characteristic that distinguishes planets from smaller, irregularly shaped objects. This distinguishes planets from smaller, irregularly shaped objects like asteroids and comets. 3. Clearing the neighborhood. This criterion is crucial for understanding the dynamic nature of planetary orbits. This is the criterion where Pluto stumbles. Despite its size and spherical shape, it does not dominate its orbital zone. A planet must be gravitationally dominant in its orbital region, meaning it has cleared its orbit of other objects of comparable size. This ensures that the planet is the primary gravitational influence in its vicinity. These criteria, while seemingly simple, have significant implications for how we classify objects in our solar system. They help us understand the complex interactions and characteristics that define planetary bodies. While Pluto meets the first two criteria, it falls short on the third. This has led to its reclassification as a dwarf planet, a category that acknowledges its unique characteristics while distinguishing it from the 8 primary planets. It shares its orbital neighborhood with numerous other objects in the Kuiper Belt, a region populated by icy bodies and dwarf planets. This bustling area of the solar system continues to intrigue scientists and challenge our understanding of what it means to be a planet. Section 4. Clearing the neighborhood. Pluto's biggest hurdle. The third criterion for planetary status, clearing its orbit, proved to be Pluto's undoing. This criterion essentially means that a planet must be the gravitational bully of its neighborhood, having either absorbed or flung away other objects in its orbital path. Think of it like this. Imagine a cosmic vacuum cleaner sucking up any debris in its way. That's what a planet does in its orbital region. Pluto, unfortunately, didn't get the cosmic vacuum cleaner memo. It shares its orbital neighborhood with a bunch of other icy bodies in the Kuiper Belt. It's like Pluto walked into a party, and instead of clearing the dance floor with its moves, it ended up being just one of many dancers jostling for space. To put it technically, Pluto's mass is only about 0.07 times the mass of other objects in its orbital zone. In comparison, Earth is 1.7 million times more massive than all the other objects in its orbital neighborhood. Talk about dominating the dance floor. This lack of gravitational dominance is a key reason why Pluto was reclassified. It simply hasn't cleared its orbital path in the same way that the 8 recognized planets have. It's like trying to parallel park in a crowded city. Sometimes you just can't find a clear spot. Section 5. The Kuiper Belt, a crowded neighborhood. To understand why Pluto's orbital neighborhood is so crowded, we need to delve into the fascinating and complex region known as the Kuiper Belt. This journey takes us beyond Neptune, the 8th planet from the Sun, and into the vast expanse of the Kuiper Belt. Named after the Dutch-American astronomer Gerard Kuiper, who first predicted its existence in the mid-20th century, the Kuiper Belt is a region teeming with mystery and scientific intrigue. This expansive area is a treasure trove of icy bodies, remnants from the early solar system that have remained largely unchanged for billions of years. Imagine the Kuiper Belt as a cosmic deep freezer, preserving these ancient objects in a frigid state, offering us a glimpse into the solar system's formative years. The Kuiper Belt is populated by a diverse array of icy objects ranging from small, comet-like bodies to larger dwarf planets, including the well-known Pluto. These objects are considered to be cosmic leftovers, fragments that never coalesced into full-fledged planets during the solar system's early history. The discovery of the Kuiper Belt in the 1990s was a groundbreaking moment in astronomy, revolutionizing our understanding of the outer solar system and its composition. It became evident that Pluto was not a solitary wanderer in its distant orbit, but was accompanied by numerous other icy bodies. This realization highlighted that Pluto was just one of many inhabitants of this frigid, distant realm. This new perspective challenged the traditional view of our solar system, where Pluto had long been seen as an outlier, the lone planet beyond Neptune. The Kuiper Belt, with its multitude of icy objects and dwarf planets, underscored the need for a more nuanced understanding of what constitutes a planet. This prompted astronomers to revisit and refine the criteria for defining a planet, leading to intense debates and discussions within the scientific community. It became clear that simply being round and orbiting the Sun was not sufficient to be classified as a planet. A true planet also needed to exhibit gravitational dominance, meaning it must clear its orbit of other debris. Despite its historical significance and size, Pluto lacked this crucial characteristic, leading to its reclassification as a dwarf planet.